Hey, Thomas, how are you?
Hi, Al. Yeah, I'm good.
All
How are
right.
you?
Thanks for making it. Excited to talk with you. Excited about what you're all are doing there at Jigsaw. So, if you would, you mind introducing yourself and maybe give a quick tidbit on Jigsaw?
Sure. Indeed, I was going to cover this a bit in the slides, but I'm a data scientist at Jigsaw, and I've been in the world of HR now for 6 months. Prior to that, I was working in fusion and physics research. And
All right.
as you've just seen in the advert before, uh, Jigsaw, we offer a platform where you can manage and do HR analytics.
So, we'll talk about this later once you get through your slides. Like, with
Okay.
that background, did you lose a bet to get into this field? I mean, and we could talk about it later, but here, I'll get out of your way and I'll let you get into your slides and then we'll talk about it. That sound good?
Okay. Yeah. Great. Thanks, Al.
All right. All right. Get after it.
Okay. Um, well, thanks for giving me the opportunity to present our work, and I'm very excited to share some of the thoughts and ideas we have. And the title of my slides here is what HR can learn from other disciplines. And I hope that you and some of the audience listening will find this insightful and hopefully useful. But indeed, as we just touched upon, as I was saying initially, a brief introduction to who I am. It gives some context of the theme of this presentation. So prior to joining Jigsaw and jumping into the world of HR, I was involved in nuclear fusion research and technology with the idea of making clean, limitless energy a near realization. And prior to that, where I started was in classical physics research. I then moved into petrochemicals and IT security. So I worked across a fair few fields, spanning various different environments, from university and academia, in private and public sector organizations, both small and very large organizations. And the consistent theme throughout has been using technology and data to do R&D, to do research. Uh, it's exactly the same in HR now. And I'd like to mention that throughout these different fields that I've been involved with, I've worked with really great pioneers and innovators in the field, and I've learned a lot. And hopefully, some of the skills I've picked up are transferable as well to what I'm going to talk about now. But first, to mention, of course, HR is doing a great job right now. And as I said, I've been involved in a lot of different environments. And everywhere I've worked, the HR departments have been great. Really compassionate and understanding, very friendly people. And HR is doing a great job. And I think we need to take a moment to celebrate that. And indeed, wherever I've worked, it's consistent. HR is much needed, and in the time of crisis now, it's even more important, I would say. So I'm going to start. Well, also mention that it's a great time to join as well because HR tech is booming. It's really great to see people adopting technology and leveraging data for good. We're really helping people with the innovative tools we have, and there are a great number of innovative tools I've seen just in the past 5, 10 years. It's really great what's going on in HR. And I thought I'd also mention here as well, spreadsheets, they get talked about a lot, and somewhat our unhealthy relationship we have with them. But maybe to reassure the listeners as well, in physics and everywhere else I've worked, we also have this unhealthy relationship with spreadsheets. We use them where we shouldn't, and they are a great tool, and they're never going to go away. But the idea is to use it when we can, for the right thing. Okay, so I'd like to talk about what we can learn from other disciplines, and first start with what can we improve in HR? Where can we look at for inspiration? So can we leverage techniques, methods, ideas from other domains? And I think we can, hence the title. But I'm going to try and help motivate you and the listeners to why I think that is the case. And I'm going to give 3 concrete examples from politics and elections to marketing, all the way to fusion. So, as I said, where I was working prior to HR. And as I said before, throughout my career, you see many problems, and you do notice a pattern of the same reoccurring problems in different domains, and you can apply the same techniques fairly easily, fairly trivially. Some problems are not so transferable, but hopefully by looking at these examples, you'll see there is motivation to look further afield. So first, I'm going to start with elections and polling. And I know in the US right now, this is a very hot topic. You have an election looming. So maybe a nice thing to start with. Indeed. So elections and polling. Why am I talking about this? Well, first, I'm British. So in the UK, we have three major parties, and we want to try and predict what the outcome of that election will be before we've counted all the votes. So we use exit polls to do that. And an exit poll is when you leave the polling station after you've cast your vote, you say who you voted for. But the crucial thing here is the numbers are really tiny. They're really small. As you can see here, only 140 polling stations were used, I think, in 2010 out of a possible 40,000 nationwide. And then of that, only a small sample, I think 200 people at each station are polled. And what you do is you're surveying these people. And so surveys are relevant in HR as well. But I want to help motivate you by saying this is the predictions and this is the results for the past three, excluding 2019, of our elections in the UK. So as I said, there are three major parties: Conservative, Labour and Liberal Democrats. And in 2010, you can see that the predicted results based on that tiny number I showed before is actually scarily accurate. It's bang on for the Conservative and a few out for the others. But that was considered somewhat a fluke, and generally you can expect 5 to 15 seat error. But something also I should mention on this slide is the Liberal Democrats, they're the third major party, but the smallest of the three. And they had quite a majority in 2010. And then the polls came out at 10 o'clock when they closed the voting, and they predicted they would lose a lot of their seats, going from 57 to 10, and nobody believed it. And then they counted the results, and it was actually worse. So that's something nice that comes up using this technique, is you actually take into account the swing states, if you will. Okay, I mentioned surveys. So why is this relevant to HR? Well, I think it's something that we encounter. Surveys are important and they provide valuable insights to our workforce. But we need to come up with a better technique than instead of just randomly sampling or surveying our whole population. You want to avoid survey fatigue, and we want to get a representative sample of our population. And can we use these techniques I've just shown? Well, the results from these techniques in polling, do they transfer to surveys? And I think we can do this. They are transferable. If you think naively that our workforce, you can think of those as the voters in the polling analogy, and then our polling stations are your offices, departments, teams. And you can imagine here that if you're an international company, you have offices all over the world. So in different countries, you have different regions, and then in those regions, you have different offices, and you have different departments, and then teams in those departments, all the way down to the individual. So you have this hierarchy, this multi-level stack that you want to probe and you want to sample. And that's one of the techniques they use in polling, is this multi-level regression with post-stratification technique. But there are really two other principles as well at play here. So you build in prior knowledge. So you build in some assumptions into your model. And you may think this is not correct to do this, but we do this all the time with models. And by doing this, you then create more powerful predictive models. So that's one of the pillars of this principle. The second one is building in historical data. So in the case of polling, you would say, I know how people have voted here before, and you take that into account in your model. And then, as I mentioned, this MRP technique, which is really taken off in the past 2 decades for polling and elections, where you take into account this multi-level theme of your population. You do a regression on this, and then post-stratification, where you adjust the estimates based on on the samples, and you can take into account small sample sizes there. It's a really cool technique, and it's really being used a lot in politics. And also psychology now is looking at this technique and adapting it for their surveys. So that's just one example of looking further afield and somewhere we wouldn't normally look in politics and elections. Now I'm going to move to something completely different and talk about what we can maybe learn from marketing and some of the things they're doing there. So marketing have really benefited from the boom of internet shopping, where you get this cheap data and you get lots of it. So every click, every mouse movement, every sort of behavior that you can imagine on the web is tracked, and there's a lot of it. And this is then very powerful if you build predictive models based on this. But the idea is not just to take snapshots of your data, so not just to take static snapshots of those instances, is to take the time series evaluation, the evolution of this. So if a client is on the website, you build up a portfolio over time and you examine the trends. That's really crucial. And then if you build in time into your models, you get far more accurate models and much more powerful. So that's something they've been doing for a long time and taking into account trends. And I know people in HR, there are some pioneers in the field doing this. And it does add a layer of complexity, but the payoff is you get a much better predictive model. So going to HR from marketing, we have a lot of time series data as well, but the time scales are maybe a bit more different. We're not looking on a time from seconds to minutes. We're looking months, years, decades even. But the techniques are transferable. And one obvious one is customer attrition or churn. If you would want to know how long someone would survive on your website, we can think of that as employee churn, how long someone would survive at a company, how long can we expect them to last. But this is also transferable to other things such as absenteeism, time until the next absence, promotion, time to next promotion, and recruitment, etc. A lot of our problems are time orientated, and once you realize this and you build time in, it makes it much more powerful for your prediction. And while I'm talking about churn as well, I should also mention maybe that marketing have also been looking at other fields for some time. So they've been using machine learning for quite a while, but also they've been looking at things like in medicine, survival analysis, and applying this to see how long someone would survive on their website, as I said, churn. And the nice thing here is you get the triggers for leaving. So that's something they borrowed from medicine and is very effective if you want to exploit, look at differences between different demographics, for example. Okay, finally, I'm going to talk about fusion. And indeed, up until 6 months ago, I was working in fusion research, and we're trying to emulate this picture I have right now showing our sun. So that is a burning fusion reactor in the sky, and we are trying to emulate that down on Earth. And it's not an easy problem to do. There are many problems in fusion, and there's a common joke that it's always 50 years away, but we are getting closer. But why am I talking about fusion? Well, I'll start by saying there aren't many fusion reactors in the world right now. And the ones that are there, they're very expensive to build, and they're very expensive to maintain and experiment with. And they also take a long time. And they're building some now. And the picture I'm showing here is the one where I used to work in Oxford in the UK. This is the Joint European Torus, or JET as it's known. Really cool piece of equipment, but indeed it's very expensive and you can't play with it. We can do experiments, but these are very limited, and you can't ask these scenarios that we really want to ask. So as scientists and engineers, we want to say, what would happen if we take all the beryllium tiles off and replace them with something else? What if we increase the neutron flux? What if we change the radius? All these things we want to ask and are fundamental to our research, but we can't do that. It's very difficult to build a reactor, and it would take years to do that. But we need to ask these questions, and there are 1,000 other questions that we're trying to answer because it's still in the R&D phase. We don't know. So we need to ask these questions. How do we do it? Well, we have the concept of a digital twin, so where we have a digital representation of a physical asset. So in this case, we build a model of our reactor, and here in this case, in this animation, is made by an ex-colleague, also at Oxford, where we are moving through a 3D model of a tokamak. So the thing I just showed is a tokamak. And this is a 3D model we've made, so it's a digital representation. And we're moving through it, and we can run physics models on here. We can change everything. It's parameterized. We can change the radius. We can change the materials, and then run a simulation to see what would happen. So we can answer these questions of what ifs. And we can do it very trivially once we invest our time in building a model. And it does take considerable time to do that. But once you do it, you can then play with it, run these what ifs, run many simulations. You basically probe your whole parameter space that's ever conceivable. And you can even reach the corner cases which you would never have thought of. So it's a very powerful tool, and it's even taking off in other things outside of engineering. So it's traditionally thought of in things like Formula One and aerospace, where you would build a virtual Formula One car. But now manufacturing and healthcare are also adopting this idea. And you can imagine this by not having a Formula One car, but having virtual patients and a virtual hospital, for example. So based on that, we can apply this to our workforce. Why can't we have a virtual workforce and do planning on that? If you can imagine the power as I described in fusion, where you want to change your reactor, well, imagine if you wanted to change your workforce. Imagine if you wanted to, in a time of crisis, fire half of your staff. Is that a wise thing to do long term? Well, okay, you put that as an input, run it and see what it says. But indeed, as I said, you need to invest time into building these digital twins. But once you have done, you can feedback and improve. And it's built on historical records. So we have data that we can feed it. We have to build in some assumptions. As I said before, this is quite common to do now in models, some basic assumptions that help us improve our model. And then some decisions. So these are our inputs. We can ask the questions, as I said, what if we fire 50% of our staff? Is that a good thing to do long term? And then you can also add in things for absenteeism and turnover and training and recruitment. All these things get fed in, and you slowly build up this digital twin, which is then, as I mentioned before, a fully digital representation of your workforce. And essentially what it boils down to is an optimization problem. And the world is filled with optimization problems, and we can solve some of these. But the problem with this is also volatility, and we need to take that into account. So supply and demand is in our workforce is volatile. But you can imagine it with constraints, right? So you say, well, I can only hire this many people in this time, and they can't work longer than this. So you have all these constraints, you feed it in, and you build your model. But then once you've done that, you can run all the predictions, all the scenarios you can imagine, and get some predictions on it. It's a really powerful tool, and something that we've been using in physics for a long time. And I think it's something that we need to be adopting in HR, and indeed people are doing this, and it's going to be very relevant for the future, I think. Okay, I'm going to finish there. I think I still have some time, but I'll summarize now. As I said, I'm sure there are people listening who are doing maybe all of these things, but indeed there are more things we can do. There are plenty more techniques and ideas we can borrow, learn, steal from other domains, and I'd be happy to talk with anyone if they are interested, or I can elaborate more on what I've touched upon today. But from what we notice when talking with people is this is not the case. Some people are even struggling to manage their data and just to get it in a digestible format. And aside from all the technical stuff, I love the optimism and enthusiasm in HR. It's really a great domain to be in. I'm happy I jumped in. It's a really nice environment and very welcoming. So I'm happy to be part of it. And thank you for listening. That's everything I have to say.
Hey, Thomas, that was fantastic. I have 100 questions, and
Okay.
let me just pick the first one. And actually, before I actually ask that first one, I just want to say thank you for choosing this discipline, because obviously, with your background, you had options, and I'm very curious as to why you chose HR and workforce planning. But before I go there, I want to ask this, particularly with the fusion discussion that you just initiated, and the idea of having a copy, a replica of what the current state is, then perform scenarios about future um, yeah, scenarios. And so there's been a lot of shall I say, skepticism around, okay, why should I plan when the world's so dynamic, where it's all changing? I, however, have pushed back or advocated that, if you actually do scenario planning, you can understand the options and the trade-offs and so forth. Yet those have largely been ethereal insofar as they've just been discussions. And what you're talking about is actually bringing data to that discussion, and you're kind of taking it out of this esoteric ethereal place and into a substantive data driven place. Is that how you view it, and how would you kind of sell this to those who, whether it be not only a CHRO but an executive team who's really thinking about how we have work to get done? What's the best means in which to get that done? Is it employees? Is it contingent labor? Is, how many of those? Do we partner with a startup, scale up? Do we automate? Do we digitize? I mean, yeah, hopefully in our very near future state, we'll have data to support those types of discussions. And that's exactly what you're bringing to the market. Is that right?
Yeah, indeed. So if I go back to fusion and physics, we have physical models. We know from first principles how things work, and we can build that in. And we also have empirical data and data we feed into the models, but primarily it's based on fundamental physics. In HR, we don't have that, right? We don't have that about our workforce. We can't use some basic laws and implement them. So that's a problem. So we have to go for the data-driven approach and build that in. But indeed, to get a fully representative model of your workforce, it takes a lot of time and you need a lot of data sources. But you can already start building smaller scale that will answer some of the questions and cover some of your parameter space. And then once you see the value in that, and hopefully if you can convince C-suite and things like that, then you can invest more time and you can try and build a better model and feed it back. Even in physics, as I said, you never get a truly 100% representative model of your real life scenario, and it's an approximation. But a first order approximation is better than just playing it by ear, right?
Right, which is what many leaders have done for a long time, and they've cited, well, I've been doing this for 30 years, therefore, we're going to make this decision. And even those who have said, well, I'm eager to learn, it invites the question, what are they learning from and who are they learning from? So if they're, that could be anecdotal feedback from direct reports, that could be reading a magazine, that could be, relying on their experience, or colleague or whatever. What you're talking about is actually taking a more systematic, disciplined, planful approach. So the pointed question that I want to ask is what you just touched on with physics versus human behavior, because many might roll their eyes and say, well, gosh, how are we going to predict organizational dynamics and human behavior? And that has been, the quest or quandary really, because quest implies that there's actually going to be a destination in time that we've done it. It's really an exploration. And so for those who are skeptical about this, what do you say to them?
Well, yeah, indeed, humans behave differently to the laws of physics, but as a population, on a population level, there are statistical, you can model them as distributions, and they are well understood in some senses. But if you go to workforce planning, for example, we know what skills our workforce have, and we know what roles we need, and we know our strategy. So those are concrete things that we can put into a model and simulate.
With your experience and background, and I touched on it earlier, and I want to give you a chance to ask, why did you choose, workforce planning and HR? What intrigued you? What brought you up? What was the gravity that brought you over? Sorry for that.
Yeah, no, it's a very good question. I get asked it a lot. I really wanted a new challenge, and I know HR. Well, HR is something completely new to me, and I saw it's something that we can really bring a bit more science and bring some of these techniques across. And I think it gives me a lot of opportunity to try and apply things that I know from a different field into the world of workforce planning, HR, and it's just something that interests me. It's a challenge. I like things that are challenging. Things that are not challenging are boring. So
Mm-hmm.
there's a lot of room for innovation, and I'm hoping I can be part of that and bring over some unique skills from a different field.
Well, I applaud that you made the decision. I mean, I already learned quite a bit from what you shared today, and it actually got me thinking about a new tact in which to sell this concept of scenario planning and workforce planning, something that leaders have been shy of in the past, particularly around the workforce because of all the noise in it. However, in this age of perpetual disruption, as I call it, with COVID and remote work and obviously social unrest, at least here in the United States, it's really important that we have some mechanism by which to not just talk about it, but actually look at data and strategize. So I applaud your work, and thanks for doing what you do. So as we start to wrap up here, can you just share how can people learn more about you and Jigsaw?
Yeah, well, I guess the first place to go is our website. You can reach out via that. You can reach out via email. You find me on LinkedIn. We have many portals to reach out. I think Hans, our co-founder, is put his email in many of the links. So yeah, just reach out.
Okay. And any final things you want to share? Any tidbits or because for one, I know you all are going to be involved next week in our conference. And so if there's any highlights that you have forthcoming, by all means, I want to trumpet them because I really am a fan of the work that you all are doing.
Yeah, that's a good thing. Indeed,
I put
what's
you on the spot, didn't
upcoming?
I?
Yeah, you have.
It's okay.
But
It's
I
okay.
must say, I love being part of HR. It's really a great to be part of this world, and everyone's welcoming, including you, Al. It's been really nice to meet you, and thank you for giving me the time and opportunity to talk.
Well, Thomas, again, thank you for being here. Thanks for sharing. Thanks for joining our discipline, and all the best. And I look forward to seeing you in person before too long. I know it's going to be a while, but yeah, I really appreciate your contribution to the space and look forward to following and learning from you as we go. So thank you.
Thank you, Al. Thanks.
All right. Thanks. All right. Well, we're going to take a short break and we'll be back with Glenn of Brussels Airport.